Okay. PPT is up. Everyone can you see the PPT? PPT is up. Okay. We'll start the session for network theory. Okay. We'll start with the demo session. This is not going to be a very big class. We will start maybe in 45 minutes or 1 hour. We will wrap up. We'll touch the basics of network theory and maybe some Ohm's law, KCL, KVL will start. Okay. My name is Utpal and I have been with IGC since 2019 and I used to teach the core subjects of your electronics, electrical and instrumentation. Digital electronics has already completed. If you have joined this year batch, then you can go through the digital electronics class. If you have joined the last year batch and if you are having the access to the last year batch, you can go through the analog electronics also. Analog and sensor optical also you can go through. If you are from instrumentation, then you can utilize that. One moment. Not visible for me. Not visible for me. Why? I can see that it is visible. Okay, people can confirm. Yashita, Manasa, Ananya, can you confirm if you are seeing the screen? So, if you have to go through the syllabus, then what you can see here is that starting with the instrumentation engineering, electronics and communication, and in the next slide we are having the electrical engineering syllabus. What we can see here is that voltage and current sources, independent and dependent. That means we are talking about some kind of sources. Okay, ideal and practical, fine. Then VI relationship of resistors, inductors, mutual inductance, capacitance, and all those things are there. Okay, that means you have to study the basic circuit elements, that is resistor, inductor, capacitor, and all those things. Then what you do, if you use a particular circuit and you connect a switch, then the output response might not be stable at once. It might take some time to get stable like this. If you have studied from your control system like that, then you have to study your transient analysis also. If you start with your sinusoidal sources, this is pretty much stable. So we have to go through the sinusoidal steady state analysis. We will study this also. All these things are dependent on your mathematical modeling, and we have to study the Kirchhoff's law, mesh and nodal analysis. In order to make our life easy, we have to go through the certain theorems. Superposition, Thevenin, Norton, maximum power theorems are there. Okay, these theorems are very very helpful in order to simplify your circuit. When we go to the AC analysis, like this sinusoidal steady state AC analysis, we will study your peak, average, RMS, and all these things are there. We will calculate power also. Okay, power calculation we will do, and then we will study the resonance, locus, whatever it is there in the syllabus. We'll try to cover. We'll start with the common syllabus, and then if there is any specific thing which is needed for a specific stream, then we'll cover that. More or less, if you see, the syllabus are almost same. In the electronics and communication also, I think most of you are from EC background, right? So in the EC background, see here it is starting with the nodal and mesh analysis, but it's not mentioned here voltage and current source. That means without voltage and current source, how you will study any network theory? No, right? So voltage and current source is inherently hidden here, and then VI relationship. This anyway you have to study. Once we start the introduction of your network theory, then you will understand what is the importance of your network theory. Why we are studying the network theory. Okay. Okay. Hello, Begum, you joined. Gana's joining? No? Just check with her if she is joining. Okay. So then again same thing here. Theorems are also there. Then steady state analysis, phasor, complex, time and frequency domain analysis. All these things we have to study. Last we have to study the two-port network theorem. Okay. Electrical engineering also syllabus are mostly same. voltage and current sources, dependent sources, RLC elements, network solution method, KCL, KVL, node, mesh, theorems, Thevenin's, Norton, superposition, maximum. So mostly there are 4 theorems that are very important: Thevenin's theorem, Norton, superposition, and maximum power. Apart from this, whatever the syllabus it is there, telegens, reciprocity, all those are from the gate point of view, it's not very much important. It's being asked in the EAC exam or any other competitive examination. Okay. Then transient response also it's there, and then we'll start with the sinusoidal response, where we'll study all those I told RMS value, AC, and all those values we'll study. Power theorem, power also we'll try to calculate. Resonance, two-port network. Some extra things are there. Balanced three-phase circuit in electrical engineering, and then star delta transformation. This should not be kept in the end, because this is somehow it should be a part of your basic analysis only, right? Because if you are having a resistive network and if you are not able to simplify that resistive network, then what you have to do, you have to go through the star delta network. Okay, that also we will study. Then power, which I already covered here, that power is there. Okay. So as I told, we'll not stretch the session. Let's not make it too much bulky in the day one. This is a demo session where the most intent or the intention is to interact with the student. That is the only one. If you have already attended my previous classes, you might be knowing that the classes are like, it's completely interactive sessions. We are going to solve a lot of questions. Here also in the network theory also, since time foundation is there, but still we will try to solve as much question as possible. Okay. Post this class, you are having doubt session also. If you are having doubt over the WhatsApp and all those platforms, you can ask your doubt. And then in the end, we are having your test series also. Test series are also performed over the time. And then faculties are available to you to support all the times. Okay. And so we'll start with the introduction, and then we'll cover basic Ohm's law, KCL, KVL. Okay. Okay. What is network theory? Anyone want to explain? They can tell what you know about network theory in the chat, on the bridge. Anyone? My old students, you should be very much active. Okay. So what is a network theory? When you study network theory, you should be knowing why we are studying the network theory. Okay. Can I say that network theory in engineering is a study of how electrical and electronic circuits and systems are interconnected and how they function? Okay, this is the theory part. But how we can study the network theory, and how we can understand the network theory? If you are having, let's say, if you want to design some circuit, then you are having a resistor R like this. Okay, I am having the capacitor C. I am having one inductor like this. Okay, like this, some circuit components are there. If I wanted to design one circuit, in moving slide, I will tell you how different circuits look like. Let's say I will take the example of a charger, mobile phone charger. Then you'll understand that there, in the mobile phone charger, there are n number of components that are placed here. Maybe a small transformer, maybe resistor, maybe capacitor. All these things are there, right? I cannot call this as a network. I cannot call this as a network theory, or study of this. I cannot call this as a network theory until all this I can connect to form a network. Okay. So can I say that the individual electrical and electronic components are there? I should be knowing the behavior of this one, and if I can interconnect this, then that kind of a study is known as your network theory. Okay. So network theory, basically we will study about the interconnection of your network elements. Okay. Then the question come, why we are studying the network theory? Why we are studying the network theory? So first, very basic and very important thing is it will help you to analyze the circuit, like inductor, capacitor, voltage sources, current sources, and all these things are there. Okay, this will help you to analyze the circuit. And why we are going to analyze the circuit, that eventually in the slides you will understand why we are going to analyze the circuit. Okay. Second is the behavioral analysis. What is the behavioral analysis? It will focus on understanding how these elements are interacted. For example, I took the example of the charger. You know that in the market there are two set of chargers are there. One is something you call as slow charging, right? You might be knowing, everyone might be knowing, this is slow charging. And then these days, it evolved as a fast charging, or someone calls as quick charging. Okay, the quick charging are there, fast charging, quick charging are there. What is the basic difference between all these things? Someone will say that this is if more than 15 watt, more than 18 watt, we call it as a fast charging. Someone will say that okay, this is, let's say 5 watt, 10 watt, we call it as a slow charging, right? But see, this was earlier, this was introduced as a slow charging charger. But when the engineers, or when the network engineers, they understood that the slow charging is not enough, they have to go through the fast charging. The circuit remains the same, right? So what they are going to do, they will play with the circuit. Maybe they can change the value of resistor, maybe they can change the value of capacitor. But in order to change the value of resistor and capacitor, they must be knowing, what they must be knowing, what does the resistor do, what does the capacitor do. Means basically they wanted to know the characteristics. What they wanted to know, they wanted to know the characteristics of network element. They wanted to know the characteristics of the network element. Once they know the characteristics of the network element, then based on the customer requirement, they can customize the charger to give a fast charging, right? So the very, very, very basic thing that a network engineer, if you are a network engineer, what you need to know is that if I am having one inductor, if variable current passes through it, the voltage is generated. If a resistor is there, if a current passes, it absorbs in terms of heat. If a capacitor is there, it will help to store the charge for temporary storage, right? But as a network engineer, you should not go deep inside this, right? How this is storing the charge. No, this is not a part of your network theory. This will come as some other syllabus, maybe EDC, or some other syllabus. It will come in EMFT. You will understand, right? But as a network engineer, you must be knowing what is the characteristics of a particular network element. Okay. So why we are studying the network theory is that the first thing is that it is the interconnected of your network elements like resistor, capacitor, all these are interconnected to form a network. Second thing is that if you are a network engineer, you must be knowing the characteristics of each network element that is being utilized in your particular circuit, right? For example, here I have taken the charger circuit. So each and every component that is there in the particular charger, you must be knowing the characteristic. Characteristic doesn't mean that we'll go deep inside the network. For example, a resistor is there, right? For a network engineer, what is important is if I pass the current, right, voltage is generated, the value of resistor is R. How V and I are dependent, how I change V and how I change I, how R is behaving. Or if R is constant, I is constant, how V is behaving. Something like that we have to study. We have to play with the variables V, I and R. But we should not go deep inside the register, how the register is designed. If the temperature is changing, then how we are going to design this. Let's say if you go inside the RTD, this is a resistive temperature detector. We should not go deep into this. As a network engineer, we must be knowing the characteristics of a network. Okay. Okay, so two things are known. Next, what next you need to know as a network engineer is, one is the predictive capability. First, that is what I told you. If you are having a slow charger, how you are going to design a fast charger is you have to play with the characteristics. So if you play with the characteristics, you must know the characteristics, right? That is what you are able to predict the behavior of the circuit if you are going to change the parameter. So if you change the parameter, how the circuit behave, you must be knowing that. Okay, so these are some theory part, but mostly you have to understand who is a network engineer and what he or she should know. Okay, who is a network engineer and what he or she should know. Then what? Everywhere mathematics is there. Mathematics is not going to leave us. Okay, so all these things are relying on your mathematics principles such as KCL, KVL, Ohm's law, network theorem. All these are mathematics only. Okay. Just tell in the chat, everyone, more or less, did you understood what is network theory and why should I call you as a network engineer? Everyone, be active in the chat. Everyone, be active. Okay, good. This is very interesting circuit. What we can see here is that everyone, if you focus here, at least I can see a battery is there, and some wire is there, some switch is there, and some bulb is there. Okay. What I can see is that this is going to be my battery. Okay. Battery is there. What else? You are having this switch. Switch is there. Okay. You are having one bulb. What else you are having? You are having this wire. Okay. Through this wire, current is flowing. Okay. Current is there. And then some charge electrons. Again, I told you we should not go into the electron flow, right? We should not go how the electron is flowing. No. What we will say that if a battery is there, positive and negative terminals are connected, then the electronic current will flow from plus to minus, and the conventional current will flow from minus to plus, right? That is the only we have to study. Okay. So if I have to tell, if I have to analyze this circuit, then first thing what we can see is that when the switch was not on, bulb was off, right? When switch was off, bulb was off. Okay. Now when I connected the switch, when switch is on, the bulb gets on. The bulb gets on. Okay. Somewhere I can see that current is flowing, right? And the direction of current is shown like this. This is your electronic current, but actually we take the conventional current opposite to this one. Conventional current, this is your electronic current. Okay. So conventional current, and this is your electronic current. Here we are, what our intention is, when I told you as a network engineer, what you should know is that there are certain components like battery is there, resistor is there, capacitor is there. When you connect that particular, all these individual components, you will form a network, right? So I will call this as a network, right? I can call this as a network, like I will call it as a bulb network. Bulb network. Okay. That means I am having a battery, I am having a bulb, I am having a wire, switch, and the current is there. That's why we are calling it as your network. Okay. We have connected like this. Now, from where we are going to study and where we are going to end. Okay. So first thing is we have to study about battery, right? If you have to study about battery, this battery can be this particular battery, we will call it as source, right? See, instead of battery, we can have a current source also, right? So this source can be your voltage source. This source can be your current source. This voltage source can be your independent voltage source. This can be your dependent voltage source. Same way. Current can be your independent current source. Current can be your dependent voltage source, a dependent current source, right? So when you start your network analysis, first thing that you have to study is your source. That's why when I told you about your syllabus, see, you always start with your voltage and current sources, independent, dependent, ideal, practical, right? Did you understand? The first thing that we have to study is your voltage and current sources. Why we are studying the voltage and current sources? This is the reason why we are, because without the voltage and current sources, your circuit will not operate, right? So voltage and current sources is the first one that we have to study. Okay. What next? Apart from the voltage and current sources, what else we have to study? See, here bulb is there, it may be a resistor, it may be a capacitor, so I will call this as a circuit element. What I will call this? I will call this as a circuit element. Circuit element can be your resistor, can be your capacitor, can be your inductor, right? So if you are a network engineer, you must be knowing the characteristics of all these things. That's where in your syllabus, the second topic is going to be the current and voltage characteristics of your network elements, such as resistor, capacitor, inductor, etc. Okay. So second thing that you have to study is your circuit element. What is the next thing? What is the next thing? Next thing I can see here is that when I'm connecting the switch, current is flowing, right? Current is flowing, in short, charge is flowing, current is flowing. So I will call this as charge, I will call this as current, right? These are called as basic quantities. What we call? We are calling it as basic quantities, right? So in your syllabus, if you open your syllabus, you will see that the third point or the third topic is going to be basic quantities. In the basic quantities, you will not only study charge, current, but you will study your voltage. Also, you will study your power. Okay. So this is how your syllabus is evolving. So as a network engineer, first thing that you have to study is your source. Second thing you have to study is your circuit element, resistor, capacitor, inductor, and third thing that you have to study is your basic quantities such as charge, voltage, power, right? This may be in any order because circuit is there. I can first study R, I can first, but these three are mandatory things. As a network engineer, you must be knowing all these things. Okay. So assume that we have studied source. Okay. We have studied circuit element. Assume that you have studied the circuit element, characteristics of your resistor, capacitor, and inductor. You have studied the charge, voltage, current, and power. Okay. Now, if I will ask you how much current is flowing into the network, in this network, how much current is flowing through it? So then what you will do, you will draw some kind of equivalent model. For example, battery I will represent like this. Okay. Switch I will represent like this. And then assume that some sort of resistor is there here. Resistor is there. So assume, right? This we are assuming. Then if I have to find what is the current, what is the voltage drop, then you have to use your basic mathematics, like not that mathematics, network mathematics, that is your KCL, KVL, Ohm's law. Ohm's law. Okay. So these we are calling it as your network analysis. Okay. Analysis of the network using KCL, KVL, and Ohm's law. So what is the next topic that we have to study in our syllabus is start with your KCL, start with your KVL, Ohm's law. All this we have to study. Okay. This is fine. This looks good. Then what? If you are having a very small circuit, I can connect this resistor like this. I can connect resistor like this. I can connect one capacitor like this. I can connect one inductor like this. This is going to be a big circuit, right? Basic KCL and KVL, it will be very difficult to find through this, right? So then again, we will upgrade our study of your network analysis to your nodal and mesh analysis. Nodal and mesh analysis, right? So next is in this particular only analysis of network theory, we will study KCL, KVL, Ohm's law, nodal and mesh analysis. Okay. See, the circuit is big. Again, if any big circuit is there, this nodal and mesh analysis, this is going to be very clumsy. This calculation and all those are going to be very clumsy. Then what comes? Then your theorem comes, network theorem. Okay. So here we will study your superposition theorem. Here we will study your Thevenin's theorem, Norton theorem. Both are same only. Somehow it's same. Superposition, Thevenin's theorem, Norton theorem, and then maximum power transfer theorem. Okay. So as a network engineer, from where we started? See, from where we started with the battery. We started with the basic source. We started with the basic source. Then in the circuit, what we looked what all circuit elements are there, R, L, C are there. Then we looked, okay, if you simply on the switch, the bulb is getting on, right? But how the bulb is getting on means some sort of charge or current is flowing, that's why bulb is getting on, right? That then you study your basic quantities such as your charge, current, voltage, power. Okay. Then in order to find the circuit parameters, maybe voltage, maybe current or parameter across a particular network element, then you have to study your basic network mathematics, that is your KCL, KVL, and Ohm's law. If you want to upgrade, if a network is big, network is clumsy, then you have to go through the nodal, mesh, and all those analysis. The substitute of your nodal and mesh analysis is you have to go through your superposition theorem. You have to go through the network theorem basically. Network theorems are there. Okay. Next what? Next what? See this, when you are making the switch on, bulb is getting on, right? It is happening all of a sudden. You can't see this also. You can't see how the switching is happening. But let's not assume directly like this. But if you are if you are making the switch on, the output is not getting stable all of a sudden, right? It is taking some time. It is taking some time to get stable. So we have to study your transient analysis also. Instead of your particular voltage source, that is your DC, we can take a sinusoidal sources also. Sinusoidal sources maybe your current sources, maybe your voltage sources. So in order to study what is the behavior of this particular sources to the particular network element, we have to go through the sinusoidal steady state analysis, sinusoidal steady state AC analysis. Okay. So this is the next topic that we are going to study, the sinusoidal steady state AC analysis. And then in order to go for modeling, we have to go for your two-port network. Okay. And some basic other things are there. But more or less, as a network engineer, you must be very clear why we are studying this, right? It's not like that you have studied your network theory and someone will ask you why you have studied the voltage, why you have studied the power. Okay, why you have studied the Ohm's law? That should not be the. If someone will ask you why you have studied the Ohm's law, you should not be saying the definition of the Ohm's law. No, why you have studied the Ohm's law? That should be the correct reason. Like the way the syllabus is getting framed. The syllabus is getting framed from your basic network theory. This is the syllabus. Okay. Tell again in the chat, everyone, did you understand more or less? Did you understand the slide, whatever it is prepared? Did you understand, everyone? Everyone, Anya, Ashwini is old student, okay. Nanya, Jaya, Begum, again old student, Mansa. Keep responding, everyone. Keep responding. Those who have joined new, those who joined recently, Vikas, Smriti. Okay, very good, very good. Okay. Session is going interactive. Okay. Slide is in a very bad shape. But yeah, you understood. I have some other animations also. But okay, let's try to override this. Same thing here. What we can see, some sort of inductor is there, some battery is there, capacitor is there. Okay. So network analysis also same applies to this also. Then what this circuit is your one battery is there, one capacitor is there. What we can see here is that when the battery is connected to the capacitor, the charges are getting aligned. Okay. So the capacitor is going to store the charge. Same analysis you have to do. What is the circuit element? The circuit element is your voltage source. And what is the next circuit element? The circuit element is going to be capacitor, right? What is important from your capacitor point of view is how the capacitor will behave if I change the voltage, how the capacitor will behave if I change the current. Okay, that's all you have to study. We should not go how the capacitor is getting designed, right? That is a part of your sensor, that is a part of your instrumentation or some other syllabus, right? Maybe some other syllabus is there, right? But as a network engineer, you should be knowing the characteristics of the circuit element. So we have to know the circuit element characteristics of capacitor. Okay, what next? Okay, so here what we can see, one transistor is there. Okay, and here one switch is there, register and all those things are there. What we can see, when the switch is getting on, the bulb is getting on. When the switch is getting off, bulb is getting off, right? Now what we need to know is, we need to know the behavior of your register, we need to know the behavior of your bulb, we need to know the behavior of your transistor, right? As a network engineer, see, if this particular LED is having a light, maybe let's not confuse with the unit, right? Let's assume that it is low or low or dim, right? I wanted to increase the light or illumination of this one. What I can do, I will pass more current. How I can pass more current? I have to play with the register. I have to play with the registers only, right? Because this transistor is working as a switch, I have to play with the registers, right? To play with the register, you should be knowing the characteristics of a register. That is the, how many times I have to repeat, I will repeat. But as a network engineer, you should be knowing the characteristics of a particular circuit element, right? Now, you have to know the characteristics of this transistor, but you should not go deep inside the transistor, how the transistor is designed, right? Because this is a part of your analog electronics, right? Now, if you want to go again deep inside this, then you have to go through the your EDC, where you can actually go and see how the electron and all those things are there, right? But your first level of analysis in your network theory is to understand that when the switch is off, this particular connection will break from your collector to emitter, right? This will break. When the switch is on, the path will be established. That's all you need to know as a network engineer. Okay, fine. Again, this slide is dirty, but you understood the intention, how the syllabus is getting formed. It's not like the syllabus is there, we have to study, just pick something and study. No, we have to study in a very sequence order. We have to start with your sources, circuit element, basic quantities, analysis of the network, and then up to here we are done. See, up to the before even nodal and mesh analysis we are done. Here we are done. Now we are simplifying our life. We are simplifying our life with the help of your nodal mesh analysis. We are simplifying our life with the help of your theorems. But before this, we have to study all these things in details. Okay. What next? Okay, this is very good diagram. If you are from electrical background, you might be knowing this. This diagram is there, right? As a some transformer is there. So here some circuit is there, and it is an equivalent circuit, right? But as a network engineer, what we have to understand, for example, if this particular transformer is giving some sort of output, right? If I want to optimize this output, if I want to change the output, I should be playing with the value of your resistor capacitor. Okay. in order to play with the value of resistor capacitor, I should be knowing the characteristics of the network element. Next, what? This is DC shunt motor. Same way, if you want to increase the speed, you want to decrease the speed, you want to improve the performance, you have to play with the network element, basic quantities, voltage, current, you have to play. Okay. This is the one which I was talking is when you are talking about your charger, where I took the example of your quick charging and your slow charging. How you're going to improve is you have to play with the circuits. You have to play with the circuits in order to you can change the value of capacitor. You can change the value of your uh, some other components are there, right? Capacitor, what is this? Transformer output wire. You can change the value of your transformer also, right? So you have to play with the network element. Next, what? Some other examples are there, like your this is what we call as inverter, right? In your home appliances. This is your rectifier circuit. Rectifier mostly you will study when you study the analog electronics. Analog electronics you will study the rectifier circuit. Okay. This is also some circuit is there. But what is the intention? What is the intention of all these two slides is, as a network engineer, you must be knowing the characteristics of your network element. Second thing, you must be knowing the sources of your network element. You must be knowing how the circuit behaves if I change the value of resistor, if I change the value of capacitor, if I change the value of inductor. That is how I am going to design a particular circuit. Okay. Okay. How many times? 30 minutes already crossed. Next is network versus circuit. Now I will pause for a minute. You already gone through some basic understanding, and we started with the network, right? Can anyone tell in the chat what is the basic difference between network and circuit? Can I call this as a network or can I call this as a circuit? Anyone in the chat? Be active, right or wrong? Be active, right or wrong? Be active. This is a network, okay? Okay, because this is a circuit. Yashita, this is a network. Okay, Manasha, it is a circuit. Okay, Ananya, circuit. Okay, good, good, good. Circuit when closed path is present, right? This is very good point. I will just note it down. Circuit when closed path is present. What she told is circuit when closed path is present. Circuit when closed path is present. That means I can break this particular network into two parts. One is when the switch is on, when the switch is off, right? When the switch is off, right? When switch equal to off, then how the circuit looks like, and when the switch is on, how the circuit looks like. So when the switch is off, you are having one switch which is open, and then the switch is open. Then you are having a voltage sources, that is battery here, and then you are having one bulb like this. Okay. Next is when the switch is on, then you are having the same switch, but it is on now, and then you are having one voltage sources. Then you are having the same bulb here. Okay, and assume that some sort of if the circuit is closed, then some sort of current will flow. That is bulb will on. If your switch is not on, then bulb will not get on, current will not flow, right? So the basic difference between network and circuit is that the network must be a circuit must be a closed path. Whatever who told? Ananya, right? Yes, because open circuit and closed circuit. Yes. So when we say that we are having a path for the current to flow, then we can call it as your circuit. If there is no closed path, we call it as a network, right? So can I call this as, right, every circuit is a network? Can I call this every circuit is a network? Yes. So can I call this every network is a circuit? No, that is not correct, right? So vice versa is not correct, right? This is your network. This is your both network and circuit. Okay. So these basic definitions are there. So I will be using some symbols, right, across the slides. That means you have to go through the self-study, because this is not somewhere we have to go very deep and details inside this. in some your college exam or somewhere conventional exam, this kind of questions are being asked, your network theory versus circuit. So you can go through all these things. Okay. Next one. Okay. Next is network analysis versus network synthesis. Anyone know on the bridge? Anyone know the difference between your network analysis and network synthesis? Tell in the chat. Anyone know? Where I told analysis and synthesis. Digital electronics. I somewhere I taught. Okay. So when we call it as a network analysis, that means network is given, right? Network. This is given. Network. Network is given. I have been given with the network. Okay. And I have given with the excitation, that is voltage source or other sources are there. So your excitation, we can call it as excitation or something, it is given, right? What you need to find is you need to find your response. You need to find your response, right? When I told you in the last slide that when we start with your voltage and current sources, then you have to go to the basic quantities and then you have to go to the analysis of the network, right? Analysis of the network is where you need to find your voltage, you need to find your current, you need to find your power with the help of certain mathematics, that is KCL, KVL. That means your network is already given. Input is already given. What you need to find is you need to find the response, right? So can we say that for a given network and excitation, you need to find the response of a particular circuit, that is called as network analysis. So network is given, excitation, this is also given, right? What you need to know is you need to find the response. Response is what? What is the response? Okay. So can we call that for a given network, for a given network, and what is given, and excitation is also given for a given network and excitation, you need to find the response. You need to find the response, right? Across the slides I use the some words like u, v, so that we can understand it very easily, but this is my own language. You have to understand, and then in your notes when you are writing, you have to write in your own language. Okay. This I use somewhere so that we can understand it very easily. Next is what? Next is your network synthesis. Network synthesis itself means you are going for designing. Network synthesis means you are going for designing, right? For example, if I take the same case of your charger, what is the requirement? Customer asks that I want a quick charging. That means, let's say, assume that I want 3 ampere of current and I want your 18 watt of your charger. Can you design the charger? And the customer is also saying that, okay, here some switch is there, go and plug and then design, right? So plug means what? From here you are having the supply, maybe to 30 volt 50 hertz, right? Maybe to 20 volt 50 hertz. So your supply is given. That means your input is given, excitation is given, output or response is given. To match the response, you need to design a particular circuit. To match the response, you need to design a particular circuit, right? So can I say that for a given excitation, this is your excitation and this is your response. For a given excitation and response, you need to find your network element. You need to design your network circuit. Okay. So what is given here? Here, network. This you need to design. What is given? Excitation. Excitation is given. What is given? Response is given. Response. Okay. So excitation and excitation is given. What is given next? Response is given. Response is given. What you need to know is you need to design, right? You need to design a network. That is your this particular one, right? You need to design a network. So can we say that for a given excitation and the response, you have to find the network element. That is, you need to design a network, right? So we can say that for a given excitation and response you need to design a network, right? So when you are designing a network, you must be satisfying the characteristics or satisfying the whatever the requirement of the customer is there. Customer said that, okay, I want 18-watt charger with a 3 ampere of current. That should be the fast charging. He assumes that 18-watt 3 ampere will be the fast charging. So you have to design that charger considering the customer requirement. That is going to be your network synthesis. Okay. What else? Ohm's law. Shall we take this or let's stop here because this is going to be first class. Let's not stretch it. Okay. Let's stop here. So when we'll start our complete class, then we will start with your basic circuit elements, and then the order will remains the same order will follow. Okay, just hold on for some time.